In this video, we'll practice determining the mode of inheritance of a given trait by looking at a pedigree. A pedigree is like a family tree in that it shows relationships between family members. Often, people use a pedigree to trace a specific trait through generations. Generally, the trait in question is a genetic disorder like hemophilia or sickle cell anemia, but you can use pedigrees to trace any trait and determine its mode of inheritance. So how do you know what you're looking at when you're seeing a pedigree? In a pedigree, we have circles as females and squares as males. Two biological parents are connected by a marriage line, and their offspring are connected by a horizontal sibship line below the parents. The offspring are listed in order of birth from left to right, with each generation denoted by a Roman numeral, and the individuals within that generation by Arabic numbers, 1, 2, 3, etc. When the sex of a person is unknown, a diamond is used to show that person in this pedigree. Now, like I said, we use a pedigree to trace traits through generations. So, often when you're looking at a pedigree, you'll see some circles and squares that are shaded in, and some circles and squares that are left unshaded. The circles and squares that are shaded in represent individuals who are affected by the trait that you're tracing, maybe affected by hemophilia or affected by sickle cell anemia. And the people that are not shaded in are unaffected by the disease. Now, what you can do with a pedigree is use the relationship between affected and unaffected parents and siblings to determine if that disease or trait that you're tracing is inherited recessively or dominantly on an autosomal chromosome or on a sex chromosome. So let's take a look at this pedigree. What we notice is that here's our original male and our original female, and they're connected by a marriage line, and then they've had children, and their children are, in the second generation, numbers 2, 3, 5, and 6. You'll notice that number 4 is not connected to the original parents because number 4 has married into the family and has kids with child number 5. You'll also notice that happening with number 7 in the second generation is marrying into this family. She is not biologically related to people 1 and 2 in generation 1, nor is number 1. So, like I said, we'll be using these pedigrees to determine the mode of inheritance of the traits that we're tracing on the pedigree. Now, there's 5 possible modes of inheritance that we'll be dealing with today: autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive, and Y-linked. Now, let's go through these. Autosomal dominant traits are traits that are carried on a dominant allele of an autosomal chromosome, which means that you only need one of the affected or dominant alleles to portray the affected trait. So people who are affected by an autosomal dominant disorder have the genotypes homozygous dominant or heterozygous for that trait. Now, what you know and what you can use to solve pedigrees is in an autosomal dominant mode of inheritance, 2 unaffected parents cannot have affected children. We know that because 2 unaffected parents would have the genotype of homozygous recessive, and therefore all of their children would have the exact same genotype and have unaffected children. Furthermore, 2 affected parents, 2 parents who have the disorder or the trait that we're tracing, can have unaffected children if the 2 parents were heterozygous to start out with. Now, an autosomal recessive trait is a trait that's carried on a recessive allele of an autosomal chromosome. That means that someone who is affected by an autosomal recessive disorder must have the homozygous recessive genotype. Now, when you're looking at a pedigree for an autosomal recessive mode of inheritance, what you'll notice is that 2 affected parents must have all affected children. That's because you have two parents. If they are affected, they must have the homozygous recessive genotype, and therefore they can only give the recessive allele to their children, and all of their children will be homozygous recessive like their parents. And two unaffected parents can have affected children if the unaffected parents are heterozygous. Now moving on to our next mode of inheritance, X-linked dominant. Now, a trait that is X-linked dominant means that it is a gene carried on the X chromosome, and it behaves like a dominant allele. Now, if you have a trait that is X-linked dominant, then the affected women will just have to have one dominant X allele to have this trait. So she could be homozygous for the dominant allele or heterozygous for the dominant allele and the recessive normal allele. An affected man would just have one X, and therefore he would have the X dominant allele. Now, when looking at a pedigree that's displaying an X-linked dominant trait, what you'll notice is that any affected father has to have all affected daughters. That's because an affected man who has a daughter gives his only X chromosome to all those daughters. If he's affected, he has the dominant affected allele, and therefore giving it to all of his daughters would mean that they are too affected. Furthermore, an affected mother could possibly have unaffected children if she's heterozygous and gives her non-affected recessive X allele to her children. Now, things are a little different for the X-linked recessive mode of inheritance. An X-linked recessive trait is on a recessive allele on the X chromosome, which means that an affected woman would have to have both recessive alleles to have the disorder. And because a man only has one X chromosome, he just has his one affected X allele to have the disorder. And a woman would be unaffected by an X-linked recessive disorder if she had a dominant X allele in a heterozygous genotype or two dominant X alleles. Now, when you're looking at a pedigree for X-linked recessive inheritance, what you'll notice is that affected mothers have all affected sons. That's because an affected woman can only give her recessive X to her sons, and the son's only getting one X from his mom, and therefore he will also have the trait or the disorder carried on that recessive X allele. Furthermore, two affected parents will have all affected children. That's because any boys of those parents are receiving an affected X from their mother, and any girls are receiving an affected X from mom and an affected X from dad. Now, when you're looking at a pedigree, you can also see an affected mother and an unaffected father will have all unaffected daughters. That's because the unaffected daughters, or the unaffected father, is carrying the dominant unaffected allele. And because of that, he will give that to every daughter, and every daughter would be heterozygous, receiving the recessive allele for the trait from their mom, but that trait isn't expressed because you're receiving the dominant allele from dad. Now, our final mode of inheritance is Y-linked traits. Now, you're not going to see any dominant and recessive inheritance here because you'll only ever have one allele. Now, this trait is carried on the Y chromosome, and therefore only men can be affected. So if you're looking at a pedigree and you think that you're seeing Y-linked inheritance, you'll notice that there are no women affected by this trait, and if a father is affected, all of his sons must be affected because he gives his affected Y chromosome to every single son. Okay, so how do we start out trying to figure out what type of mode of inheritance we have in a specific pedigree? First, what I like to do is list all my possible modes of inheritance, so as I read through the pedigree, I can cross them off one by one. Now, I always put Y-linked at the top of my list because it's the easiest to rule out or support, and then I move through the autosomal and then X-linked modes of inheritance. Now, when I'm looking at a pedigree and trying to figure out which mode of inheritance the pedigree is displaying with the given trait, what I like to do is look at just one small family and rule out as many modes of inheritance as possible, and then look at the modes that I have left in relation to the larger pedigree. So, I'm going to start with this small family here, and I'm going to see that, first of all, I have a female that is affected, which automatically tells me that the trait is not a Y-linked trait. We understand that Y-linked traits only affect males. Now, as I look at this family, what I notice is I have two unaffected parents having, here are my two unaffected parents, having an affected daughter. Now, if that's the case, we automatically know that this trait is not inherited in the autosomal dominant mode of inheritance. The reason we know that is that if it were an autosomal dominant trait, then that means that this affected girl would have to have at least one dominant allele, which she would have had to have received from one of her parents, which means that at least one of her parents would have had to have had the big R and therefore be affected, and they are not. Therefore, we can cross off autosomal dominant, and the same rule applies for X-linked dominant. Okay, so now our only two modes of inheritance left are autosomal recessive and X-linked recessive. So let's take a peek at what the X-linked recessive mode of inheritance would look like on this pedigree. Now what we know is that if it's an X-linked recessive mode of inheritance, then females have to carry both recessive X alleles to show the trait. So this female would be X-linked recessive for both of her alleles, which means she would have had to have gotten her X-linked recessive allele from her dad and from her mom. Now, if the father did have the X-linked recessive allele and his Y allele, then that would mean that he would have had to have been affected for this mode of inheritance to be plausible for this pedigree, which means we can also rule out our X-linked recessive as a mode of inheritance on this pedigree. And that leaves us with autosomal recessive as our mode of inheritance. So let's go ahead and take a look at what that would look like. We understand that any affected individual must have the homozygous recessive genotype. So all of these affected individuals have the homozygous recessive genotype. Now, is that possible? You can have an affected child from unaffected parents if the unaffected parents are heterozygous. They can have heterozygous or homozygous babies. And if that's the case, we can fill in all of these genotypes, and we see that this is completely possible in this pedigree. And so our final answer would be that the mode of inheritance for this pedigree is autosomal recessive, and that is the only option. Okay, let's take another crack at it. Here's our second pedigree, and we're going to go ahead and start off by saying we see that women are affected, and because women are affected, we know for a fact that this is not a Y-linked pedigree. We can cross that off. Now, what we are also seeing is that we have a lot of couples that have two different phenotypes. So, let's take a look and see if autosomal recessive would work as a possible mode of inheritance here. If autosomal recessive were the mode of inheritance here, what we know is that all of our affected people in this pedigree have the little r genotype. Now, that would just have to mean that for this couple to have an affected child, the father would have to be heterozygous. The same would go for this mother because she has affected and unaffected children, and the same would go for this mother. So what I'm seeing is that autosomal recessive is a completely plausible mode of inheritance for this phenotype, for this pedigree. Now our next possibility is autosomal dominant. Now we understand that anyone who is autosomal dominant and affected could be heterozygous or homozygous for the dominant allele, and anyone who's unaffected would have to be homozygous for the recessive allele. That would look like this. So when you fill in all the genotypes, it's completely plausible that this trait is inherited on an autosomal dominant mode of inheritance. Now our next possible mode of inheritance is X-linked recessive. Now, if something is X-linked recessive, that means that the individuals who are displaying the trait are having XR for all of their X's. Now that means that the men who are affected would have to have XRY, and the women who are affected would have to be XRXR. Now we also know to be unaffected, women must have at least one non-affected X chromosome, and men must have only, their one X can only be the normal X, not the affected X. So if we fill in the rest of these, what we notice is that X-linked recessive is completely plausible as a mode of inheritance on this pedigree. Now, our final possibility would be the X-linked dominant mode of inheritance. Now, I'd like to draw your attention to this small family down here. We remember that if we have a father carrying the X-linked dominant allele, then all of his daughters would get this X-linked dominant allele, and therefore they would be affected. What we see here is that he has a daughter who is affected and a daughter who is unaffected, and therefore we can rule out X-linked dominant just from that small family. We can rule out X-linked dominant as a mode of inheritance for this pedigree. So what we've come to, our conclusion that we've come to here is that this pedigree, the trait in this pedigree, could be represented by any of these modes of inheritance, and we would need more information to further discern the actual mode of inheritance for this trait. Okay, so on to example number 3. What we immediately notice about this pedigree is that there are women affected, and therefore this is not a Y-linked mode of inheritance on this pedigree. Now, what we are noticing is that we have couples that have different phenotypes having children of different phenotypes. So, could this possibly be an autosomal dominant mode of inheritance? Let's try it and find out. So, if this were an autosomal dominant mode of inheritance, this person, this father, would have to be big R, little r. We know he has to have a little r because he has children that will be little r, and his wife is little r. So he has children that inherit his little r and some children that inherit his big R. Now, we also know that this person, this father right here, would have to be homozygous recessive if this were an autosomal dominant disorder. So he would have to be little r, and he could have either homozygous children or heterozygous children that display the trait. So, looking at this pedigree, we can say that autosomal dominant is a possible mode of inheritance for this trait. Okay, now on to testing autosomal recessive. We understand that if a trait is passed down on an autosomal recessive mode of inheritance, then those who are affected will be little r, and those who are unaffected would be heterozygous or homozygous dominant. Let's see if that would work. And indeed it does, so we can say that autosomal recessive is a possible mode of inheritance for this trait. Now moving on to X-linked recessive and X-linked dominant inheritance. Now, let's draw your attention to this family right here. If this trait were an X-linked recessive trait, then this mother would have to be XRXR, which means she would have to give an XR to all of her sons, and they would all have to be XRY. Because they are not all affected, we can rule out X-linked recessive as a possible mode of inheritance for this trait. And our last question is this possibly an X-linked dominant trait? Now, let's take a peek at this family right here. we understand that if this were an X-linked dominant mode of inheritance, then this son would have XD, Y, and he would have received his X from his mom. Now, that means that the mom would have to have XD and something else. But we understand that just having one dominant X allele means that you would have to be affected by the trait. And because this mom is not affected by the trait, we can rule out X-linked dominant as a possible mode of inheritance for this pedigree. That leaves us with the possible modes of inheritance for this pedigree are either autosomal dominant or autosomal recessive. Okay, in this next pedigree, we'll be looking at something a little bit different. Now, what we immediately see is that the only people who are affected are males. That might lead you to believe that you have a Y-linked trait here. However, you should remember that any type of Y-linked trait requires the father who carries that affected Y to pass it on to all of his sons, who would then also carry the affected Y. Because that's not the case here, and this son should be affected but isn't, we can rule out Y-linked as a possible mode of inheritance for this pedigree. Now, something you need to notice about this pedigree is that this trait, this being affected, actually skips generations. We can see the trait in generation 1 and in generation 3, but not in 2 or 4. That tells us, when we see any type of skipping of generations, that it cannot be a dominantly inherited disorder. Because anytime a dominantly inherited disorder is passed down, it has to show up in the phenotype. Therefore, we can rule out autosomal dominant and X-linked dominant as possible modes of inheritance for this pedigree. Now, autosomal recessive. Is this an option? If autosomal recessive is the mode of inheritance for this pedigree, then male number 1 would be little r, and this female would have at least one big R. We know that these other two affected men would be little r, and therefore their parents would have to be heterozygotes. And if their parents were heterozygotes, then that means that we see a heterozygote here and here. And it doesn't even matter what this mother has. This is a completely possible scenario where all of these children could come from these two parents. Therefore, we can say that autosomal recessive is a possible mode of inheritance for this pedigree. Now, our final question is this an X-linked recessive pedigree? Now, if it were an X-linked recessive pedigree, we know that these boys who are affected would all have the XRY genotype. And we would also know that that XR that all the affected men got came from their mothers. And as we can see, this is a completely plausible option, so we would say that this pedigree could be X-linked recessive. And our final conclusions, not given any further information, is that this pedigree could be autosomal recessive or X-linked recessive mode of inheritance. Okay, in this next pedigree, what we automatically realize is that the one person in this pedigree who's affected is a female, so we can start off by eliminating Y-linked as a possible mode of inheritance for this pedigree. Now, we are also seeing, again, that skipping of generations of the affected people, of the affected trait. Because this person who is affected has two unaffected parents, we know already that we can cross off autosomal dominant and X-linked dominant from our list because a dominant allele would show up in every generation as it moves down the pedigree chart. Now, could this possibly be an autosomal recessive disorder? If that were the case, then person 2 in generation 2 would have little r, and every other person would be at least heterozygous, if not big R. Now, is it possible that we could have a little r baby from two non-affected parents? The answer is yes. They would just need to be heterozygotes themselves. So, from this, what we can assume is that autosomal recessive is a possible mode of inheritance for this pedigree. Now, is X-linked recessive a possible mode of inheritance for this pedigree? If that were the case, we would know that this person that is affected would be XR, XR, meaning that she got her affected X from her father, and his genotype would be XRY, which would make him have to be affected. But because he is not, we can rule out X-linked recessive as a possible mode of inheritance and say definitively that the only possible mode of inheritance for this pedigree is autosomal recessive. Okay, in this pedigree, what we notice right off the bat is that the only individuals affected are males, and we are not skipping any males in the line of descendants. So it is quite possible that this is showing Y-linked inheritance. Now, what you'll also notice is that we are missing a lot of partners in this pedigree, and therefore that's the only type of inheritance that we can definitively say yes to until we have more information. However, it is good to see this pedigree as a good example of Y-linked inheritance flowing from father to son, and to son. There's no skipping of generations with Y-linked disorders. Okay, in this pedigree, right off the bat, we see that there is a woman affected and a man affected, so we can cross off Y-linked as a possible mode of inheritance. We also notice that this is a trait that is skipping generations. That lets us cross off autosomal dominant and X-linked dominant as possible modes of inheritance. Now, let's take a peek at what would happen if this were an X-linked recessive mode of inheritance in this pedigree. What we know is that let's take a look at these two cousins who are having a child right here. Now, if a woman is affected by an X-linked recessive disorder, she must have the XR genotype. If that's the case, we know she gets one of these XRs from her father, who would therefore be XRY, and he would be affected. Because this father is unaffected, we can cross off X-linked recessive as a possible mode of inheritance for this pedigree. Now, could autosomal recessive work? Let's check it out. And what we see from the genotypes I've filled in and what we can infer for the rest of the individuals in this chart, that autosomal recessive is the only possible mode of inheritance displayed on this pedigree. Okay, in this final pedigree, we can start out like we normally do, saying, okay, is this a Y-linked trait? And we see that women are affected, so we know that we can automatically rule out Y-linked as a possible mode of inheritance for this pedigree. Now, what we're seeing is that we're seeing a lot of parents with opposite phenotypes. In that case, what we can't do is automatically rule out autosomal dominant. So, is autosomal dominant a possibility here? Let's check and see if it is. And from what I've filled in, you can see that it is absolutely a possibility, so autosomal dominant is one of our possibilities. Now let's check autosomal recessive. Now we know that if autosomal recessive was the mode of inheritance for this pedigree, anyone who is affected would have the genotype r, which would mean that anyone unaffected on this pedigree would have to be heterozygous for this to work. But if that is the case, then autosomal recessive is a possibility for this pedigree. Now to check for X-linked recessive inheritance, let me draw your attention to these parents and children right here. What we do know about X-linked recessive inheritance is that a female who is affected would have to have XR, and she would give this XR to all of her sons. And when she gives that XR to all of her sons, they would all have the exact same genotype of XRY, and they would all be expected to be affected. Because they are not, and she has one unaffected son, we can rule out X-linked recessive as a possible mode of inheritance in this pedigree. And finally, we can check for X-linked dominant. Now let's draw your attention to this family right here. If something is inherited on the X-linked dominant allele, then we know that anyone who's affected carries that allele. Now this father has the X-linked dominant allele and his Y allele, and we know that he gives his X allele to all of his daughters. If he is giving that to all of his daughters, then they would all have the XD allele and therefore all be expected to be affected. Because they are not, we can rule out X-linked dominant as a possible genotype or a possible mode of inheritance for this pedigree. Now, because we've gone through our entire list, we can definitively say that this pedigree could result from autosomal recessive or autosomal dominant inheritance, and we would need further evidence from this family to be able to choose between those two options. So there you have it, the basics of reading a pedigree and some practice problems to work from. If you would like more practice, go online and Google any type of pedigree or just Google blank pedigree, and you'll be able to practice identifying the mode of inheritance running through any pedigree.